So any topics, are you guys facing any challenges? Yes, Anupama, that is correct. So your training data is like a question bank. Okay. We have question banks. So remember when you were preparing for exams, we used to prepare from a question bank. And then we used to write our actual exam, right? So this question bank that you use is the training data. And the actual exam that you write, that is your test data. So this is how we evaluate, right, Anupama? In real life also, you study from a question bank, right? You prepare from books and from question bank, and then you go and appear in the exam. So this is how it is evaluated, right? And the exams are supposed to be on the same concepts that is taught in the school, right? Or on the same concepts that are present in the question bank. But still, the questions that actually come in the exam might be slightly different. So this is a very good analogy to understand why do we evaluate the model on test data. Because I cannot, so if all the questions in the exam come from question bank, then there's no point of the exam, right? Somebody who have memorized the questions will also be able to answer well. That is why you have a few questions which are on the same topic but slightly different. So Vinith is asking, is there any difference in coefficient for multinomial regression when we calculate them by OLS regression and by scikit? No, there is no difference. Even the sklearn package does the same thing. So there is no difference in it. Both will give you the same result. The underlying algorithm is the same. They all try to minimize the sum of squared error. So in regression, OLS, ordinary least square, they all try to minimize the sum of squared error. So they give you the same solution. There's no difference. What else, guys? There are a lot of opportunities. I see a lot of opportunities for entry level data science roles also. So are you guys applying? Have you guys given any interviews already? Okay, so where did you give it? Which organization and how did it go? Oh, Mu Sigma. Okay, how did it go? Yeah, Vinit. So maybe you can share the questions. You can use the WhatsApp group and share the questions on WhatsApp group. Okay. So Anupama is asking a question. The model which performs good on training data and not good on test data. Yeah, that is the concept of overfitting, Anupama. We have discussed this extensively. So the concept of overfitting is where you perform very well on training data, but not so well on test data. This is overfitting. So this has been covered in details. So I'm not sure if you missed it, but we have a separate module for this. So overfitting versus underfitting. But in real time, how do we evaluate this? I do not follow your question. So you have your training data, you have your test data. You can always calculate the error you are making on training data, and similarly, you can always calculate the error you are making on test data. And if you find that the accuracy on training data is high, let's say it is around 80%, and the accuracy on test data is less, let's say around 60%, that means the model has overfit. The model has memorized some of the pattern in training data, and that is why it is not able to perform well on test data. Okay, so you can always evaluate it in a simple way, like checking the accuracy on training data and checking the accuracy on test data. That's how you evaluate it. It is like you are memorizing all the questions in question bank. Okay, so before you go and write an exam, you are memorizing the questions in the question bank, and as a result, what is happening is you're not able to perform well. So you are not understanding the concepts that are present in the questions while you are training. You are memorizing the question, the answers, and that is why you're not able to perform well in the actual exam, which is called overfitting. So this happens in real life also, right? Sometimes we do memorize questions, we do memorize answers to certain questions in the exam, and whenever we get a question in exam which is slightly different, we are unable to solve it because we had memorized it and did not understand the concept. So the same concept is what is called overfitting. Any other questions, guys? Okay, Naresh is asking, what if we will be more accurate on test data than on training data? Naresh, this generally does not happen. Okay, this will happen only if your test data is very small. If you take a very small test data, only then this can happen. Otherwise, this never happens. Why this never happens? So take the real life example. If you have not prepared well in your exam, if you have not prepared well for your exam, it will very rarely happen that you still perform very well. So that only happens when you are very lucky. When you are very lucky, when you have not prepared well for the exam and still you perform well. So that happens when you are very lucky. And when can you be very lucky? When only a few questions are asked in exam. If only two or three questions are asked in exam, then you can be lucky, right? But if your exam is a rigorous exam which asks a lot of questions, then you will not be, you will have very less chance of being lucky. So that is why I say that that can only happen if your test data is very small. So we try to keep at least 20% data points in test data. At least 20% we keep. Because if you keep just 10%, then the number of points in test data might turn out to be very less. And if the number of points turn out to be very less, that means you are not evaluating your model well. You are evaluating your model on very few points. And so the model might turn out to be lucky. So to avoid the luck factor in, we keep at least 20% in the test data. Do you follow, Naresh? Okay, you witnessed this logistic case study. Okay. So did the question did the question ask you to split the data in some particular ratio? Okay, and how much accuracy did you get in training and in test? Can you tell me? Do you remember? Okay, okay, that was a slight difference. Naresh, that much difference is okay. Yeah, that difference is okay. See, a plus minus 5% is okay. That is random variation. You cannot call that is performance is better on test just because it is zero point 0.5 greater. See, plus minus 5% up and down is okay. This is random variation. This is just random variation. You cannot call this that I'm performing better in test and lesser in train. Obviously, it will have some random variation. Right? It will not be exactly 88.1. It will never be. This is random variation. So this cannot be called as performing higher in test than in train. Okay. This is so plus minus 5% variation is okay. That is okay. That is seen because the points are different, the questions are different. So obviously you expect to see some variation. Okay. Anupama has asked a question. In Python, we build model on training environment test data. Okay. No, Naresh, it's correct. Not sure how to evaluate training data. So Anupama, you can evaluate training data in the same way you evaluate test data. So you use the name of the model, right? Let's say you have built a logistic regression model. So you write, how do you predict on test data? You write log reg dot predict, and then you write x of test, right? This is how you predict for the test data, right? Let's say you store it in pred, and then using this pred, you build your confusion matrix. So to evaluate on the training data, the process is the same. Just instead of X test, you write X train. If you write X train, that means you are predicting for test data, for training data, sorry. That means you are predicting for training data now. You know your actual values of training data, actual Y of train you know, and using this, you can predict for, you know your predicted Y train. So you know your predicted Y train and you already know your actual Y train. Now you can compare them. Yes, that is why we don't evaluate it. That is why we don't evaluate it on the training data. We evaluate on the test data. So you will very rarely see this. But we have to do this if you want to check for overfitting. If you want to check for overfitting, you will have to do this. You will have to find your training accuracy and you will have to find your test accuracy. Only then you can check for overfitting. You have to find both. Yes. Any other questions? Any books to refer? So Naresh, right now I would not refer any books. Okay. There are a few additional materials I have already shared with you within the LMS itself. So within the LMS, if you see, I have shared certain pages from some books. I have asked you to read certain pages from some books so you can follow that. So for example, if you go to cart, in some places I have given references. So let's say I don't remember where, but I do have given some references. So wherever I feel some additional material will help you guys, I have given those. Okay. So I would not advise any other books at this point of time because you guys are already going slow. I don't want you to slow you down further. So completing the topics on time is very important. Okay, because guys, the competition is not waiting for you. Always remember, the competition keeps increasing every month. So the more delay you are doing, the more difficult it is becoming for you guys. So try not to go slow. Try to go as fast as possible. Okay. So I have seen how the competition has increased. Okay, I have been in this field for quite long now. So the competition has increased a lot in the last maybe 6 months to 1 year because there are thousands of people, other students like you guys. who are also trying to study and go into the industry. So get ready soon. Don't delay. Okay, I'm not able to find, but I do have shared a few questions, a few material. I have shared one book. I have shared the theory from a book. I don't remember where it is, but this one. So, for example, this one. I have shared many places the theory from this book, but I did not share this book explicitly because this is in R. This is not in Python. Okay, but the theory content in this book is very good. So, if you really need any books to refer, you can refer the theory from this book. Okay, so this is a free download book. You can download it for free. Okay, so I have already given the book here. So you just click here and you can download. And I have given the page numbers also that you should refer. So for example, for this topic, you need to refer pages 176 to 178 and so on. And guys, I have made this course open now. So this course that you are taking, so you guys are taking it in live mode, but I have made the course open for anybody who wants to take it in non-live mode. Okay. So the fees for that course obviously will be lesser. So the fees for that course is 12,000. So if any of your friends are interested, do let them know. Okay, so they won't be able to attend the live classes that you guys are attending, and so but all the LMS, all the content on LMS and everything, they will also have access to. Okay, so everything remains the same except the online classes. They will not be able to attend the online classes. Okay, so let's begin with today's topic, guys. So how many of you have seen last class's video? Because the topic that we will be discussing is directly related to what we studied in the last class. So the last class, the last topic that we had was, it is here. So cross validation. So we'll be looking at the codes for cross validation now. Okay. So I don't think any of you have gone through last class's video. So let me quickly revise the things for you. Okay. So remember, guys, we have completed a few algorithms so far. So we are currently going through supervised learning. Okay. So if you remember, what is supervised learning? Supervised learning is all about finding this function f. So we have we have dependent variables in any business problem, and we have independent variables in any business problem. Okay. Now what we are interested in any supervised learning problem is finding the values of dependent variables for different values of independent variables. So independent variables are known to the business. What is not known to the business is what is the value of the dependent variable. So for example, sales of a company. So a company might want to know what would be its sales in the next quarter, in the next year, or whatever. And what the company may know already is the investments they make. Let's say the investments they make, the marketing budget, and so on. So this is what the company can decide or can change. Okay, the company has the power to change this, but the company does not have the power to change this. They can obviously try to increase this by varying different values of this, but what the company wants to know is what would be its sales given that some amount of investment has been made, given that this is the value of marketing budget, and so on. So what we try to do in supervised learning is we try to find this function f. This is the goal in supervised learning. We try to find the function f. What is that function f which gives a relation between these two quantities? So we can have multiple independent variables, of course. I have just written one here for simplicity. So the goal of supervised learning is what is that function f which gives a relation between the two. Now we use the training data to find this relationship. We use the training data to find this function f, and once we have found this function f, what we do is we give all the values of x in the test data, and we find the predicted y hat. We find the predicted y, and we also know the actual y in our test data. So we know our predicted y, we know our actual y, we compare them and then we check how accurate is the model. Okay, and if we are happy with that model, we use the same function f to predict for the future. So this is how we proceed. Now so far we have seen a few algorithms. We have seen, again, supervised learning is divided into two parts. We have seen that one is regression, one is classification. Regression is where dependent variable is continuous. Classification is where dependent variable is categorical. Okay, under regression we have seen linear regression, and under classification we have seen logistic, and we have seen decision trees which can be used for both. We have seen decision trees as well, which can be used for both regression and classification. Okay, how long was I on mute? Were you able to hear me when I described what is regression, what is classification? Okay, so we all know this. Okay, good. So we know what is regression, we know what is classification. We have covered linear, logistic, and decision trees. Okay, now linear and logistic are known as parametric models. Why are they called parametric models? Because they assume some underlying distribution of the data. So for example, linear regression, if you go back to the assumptions of linear regression, you will see it has a few assumptions. So for example, one of the assumption is that the dependent variable should have a linear relationship with the independent variable. Okay, so these assumptions are present in linear as well as in logistic. In logistic also you have some assumptions like the log of odds. Log of odds should have a linear relationship with the independent variable. These are the assumptions in linear and logistic. Or in other ways you can say they come with specific equations. So for example, linear regressions equation is beta naught plus beta 1 x1 and so on. Similarly, logistic regressions equation is probability of y is equal to 1 is equal to this, where theta is this quantity. So they come with certain equations, or in some way they are fixed. This will always be a straight line and this will always be a S curve. Logistic regression will always be a S curve. So they are fixed. Their shape won't change a lot. Okay, so that is why they are called parametric models. Now decision trees, why are they different? Decision trees, they are different because they don't come with any shape. They can take any non-uniform shape. So decision tree, which we have studied already, they don't have, this is a non-parametric model. Okay, so they don't have any particular shape, they can take any shape they want. Okay, so that is why they are called non-parametric model. Now, non-parametric models, they suffer from a disadvantage called high variance. Now again, all of this has been discussed in details, so you will only follow this well if you have gone through this module. Okay, so go through this module and then it will be clear to you what is high variance. This has been covered already in the class. Okay, so this they suffer from a disadvantage called high variance, which on a high level means that if you change your data, the model changes a lot. Okay, if you change part of your data or if you change a few data points, the model changes a lot. Now why is that a disadvantage? That is a disadvantage because the model that you come up with may be very inconsistent. If the model is a high variance model, the model might be very inconsistent because it might predict something now and it might predict something else later. So if you change slightly your test data, the model will start predicting a lot of, so there will be a high variance in the prediction of the model. That is why it is called high variance model. Okay, so this is one disadvantage of all non-parametric models and decision trees in particular. So how do we avoid this disadvantage? Now we have also seen that decision trees have certain parameters. So for example, max depth is one of the parameters. So max depth is like how deep will be the tree. So for example, if you split once, this is depth 1. If you split twice, this is depth 2, and so on. This is depth 3, and so on. So max depth is one parameter in decision tree, and similarly we have another parameter called min samples leaf. Okay, min sample leaves, what does this parameter do? So this parameter decides the minimum number of points that should be present in the node to continue for a split. So let's say if you give min sample leaves as 20, and let's say you have let's say 40 points at this node right now you have 40 points at this node. Now if the split happens here, and if you end up having let's say 30 points in one bucket and 10 points in the other bucket, then min sample leaves will avoid this split. So how will it avoid this split? Because this 10 is lesser than 20. So whichever split results in a bucket having less than this quantity, whichever split results in having a bucket which gives you less than 20, min sample list will not allow that split. Okay, so in other words I can say both these parameters are used to control overfitting. They are used to control overfitting because the more splits you make, the more overfitting can happen. Okay, as you go on splitting the data, chances are that you will go on overfitting on the model. Okay, that is why we try to control or we try to restrict the tree. We don't want our trees to be very long. We want to control them. Of course they should not be very small also, because if they are very small it will underfit, the model will be very simple. So we want it to extend but not beyond a certain point. So that is why these parameters are very important, because these parameters allow you to control the tree or restrict the growth of the tree. Okay, now last class we discussed what is cross validation. So how do you decide the right value of these parameters? So that process is called cross validation. Now you may wonder why don't we just decide looking at the train and test data? So what we can do, or what we usually also do, is we train our model on the train data and then we keep looking at the test data. We check the accuracy at test data for different values of the parameters. So let's say max depth. I'm just talking about max depth for now, but the same concept is applicable for min sample leaves also. So let's say max depth you will start from 2 to 10. Okay, so 2, 3, 4, all the way till 10. Now what do? You check the test data accuracy for max depth of 2 Then you check the test data accuracy for a max depth of 3, 4, and so on till 10. And let's say you find that the max depth is best at 4. Sorry, the accuracy is best at 4. So for all these values of max depth, you find your accuracy on test data, and you found that at max depth of 4, the accuracy on test data is the best. So what will you do? You will freeze the value. You will finalize the value that max depth is equal to 4. So this will be your final model, which will have max depth is equal to 4. Okay. So this is the process that we usually follow, but this is wrong. Why is this wrong? Because this max depth of 4 may not be applicable for all future test data. So test data is, this is just a dummy test data that we have prepared. The actual application of the model will be when it predicts for future. This is a test data that we have kept from the data that is given to us, but this model will be used for future prediction. So we are not sure, or we cannot guarantee that this same value of max depth will also apply in the future, because this is particularly for this test data, not for the future. May not be for the future, may be for the future, we are not sure. So this is the disadvantage of doing this, of finalizing the parameter value using just the test data. This is the disadvantage, because that particular value of the parameter might be good only for that particular test data, not for all test data. But what we want out of our model is that it should predict good on all future test data, not just one particular test data, but it should be consistent performer, not just good performer on one particular test data. Okay, so that is the challenge. Another challenge also is that whenever we build a model on training data and predict on the test data, the goal is to keep the test data independent. The goal is to keep the test data independent of the model building process. While you are building the model, you should not know anything about the test data. Just as while you prepare for an exam, you don't know what questions will be coming in the exam. Okay, so you should prepare independently and then go and write an exam. But what are we doing here? We are we are deciding based on the performance on all these values. So we are looking at the test data performance on 2, on 3, on 4, and so on, and then deciding that okay, at 4 it is the best. So this is like we are going to the exam and then coming back and then deciding what is the best value. Ideally, we should not decide looking at the test data. So these are the two reasons why this process is kind of flawed. Okay, so what is the solution then? What is the solution? The solution is what is called cross validation. So we discussed a concept called leave one out cross validation. Again, this is discussed in details, so you should go back to the previous class and watch this. And then we discussed k-fold cross validation. We discussed what is k-fold cross validation. So what is k-fold cross validation? So in this, what we do is we take the training data. So we take the training data, and then we obviously take the test data also. We take the test data also. Now within the training data, what do we do? Now this training data, what we will do? We will divide the training data into k parts. We divide the training data into k parts. So let's say k is equal to 5 for us. That means we will have 1, 2, 3, 4, and 5 parts. Okay. So these are not just 5 rows, these are 5 parts. Each part will have a few rows. So let's say this has 100 rows, this has 100, this has 100, this has 100, and this has 100. So we had a total of 500 data points in training. We had divided that into 5 parts, each having 100 parts. Now, how does k-fold cross validation proceed? So here, what do we take? We divide these parts into training and validation. Okay, we call it validation or test also. A lot of people call it the test data also. But remember, we have a test data separate. We have this test data which is separate. So this has 500 points, and let's say this has 120 points. Okay, this is your final test data. But within the training data, you divide your data into training and validation or test. Okay, so what do we do? We take 4 parts here and the fifth part as the test data. So we will build a tree on this. Let's say tree 1. We will build a tree on this, and we will predict on the fifth part. Okay, we'll predict on the fifth part, and we calculate the accuracy. Let's say A1. I call it A1. Similarly, I repeat the process. Now we will build the tree on these four parts and predict on the fourth part. And I will call this accuracy 2, and so on. So this process will go on k times. I have k I have k parts of the data. So 5, 4, once 3 will come, once 2 will come, once 1 will come in the validation set. So you will end up having k is equal to 5 models. So you will have 5 models here. So you will get 5 accuracies. You get 5 accuracies corresponding to each model. Okay. So this is how k-fold cross validation works. And then the accuracy that you report. Now Now, what accuracy will you report? You will report that your model has a accuracy of the average, whatever is the average. So A1 to A5. You will report that the model's accuracy is whatever you get as the average. You will not report whichever is the best one, because that best may be only for a particular test data. Let's say A1 is very good, but A1 is very good only when you are testing the model on the fifth part. On the other parts, it is not good. It may not be good. So what we do, we average it, so that the final accuracy that we get is more consistent, because sometimes you will see higher, sometimes you will see lower, but on an average this is what you will see. Let's say this is 78%, let's say this was 82%, this was 85, this was 68, this was 72, and this was 74. Okay, so these are the accuracies that you saw. But when you finally report on your model, you will report the average of all of them. So what is the advantage? The advantage is that your model will usually give you an accuracy of 78%. Okay, if you report 82, then if your actual test data, the test data which is present here, if that test data is like the fourth part, or if it is like the first part, then your accuracy will be different. So you want to show that whatever accuracies you are telling, that is what will remain in the future. So you will take the average. So this average will be a more consistent value. Your model will consistently perform somewhere around 78% than around any of these particular numbers. Okay, so this is the process of cross validation. Now, one other application of cross validation is parameter tuning. Okay, one other application is parameter tuning. What is parameter tuning? So we talked about certain parameters in decision trees. We talked about max depth. We talked about min samples leaf. Now, how do we decide the best values of these parameters? How do we decide that what value of max depth should we take, or what value of min samples leaf should we take? So that also can be decided using cross validation. So what process is followed is this. So again, we will use k-fold cross validation. So what we do is we divide the data into 5 parts. Let's say k is equal to 5. Then we will have our training, we will have our test. So 1, 2, 3, 4 into training, and fifth into test. Okay. So while this is the data, we will build a model, and in that model we will give a few values of, let's say we are trying to find the best value of max depth. Okay, let's say we will vary it from 2 to 10, and we will see what is the best value within 2 and 10. So we will create a model, and we will calculate the accuracy of the model on this data for max depth of 2. Okay, for a max depth of 2, and let's say we get accuracy A1. For a max depth of 3, and let's say we get accuracy A2, and so on till 10, and we get accuracy of A10. Okay, so these are the accuracies we get for different values of max depth for a model built on this data. Okay, now we will change the data. 1, 2, 3, 5, and 4 will come here. Now notice the model is the same. I'm not changing the model. My model is the same, my data is changing. Okay, only my data is changing, my model remains the same. And now I repeat the process. Once again, I will check for depth of 2. I get, let's say, accuracy, some accuracy, A-1. At depth of 3, I get A-2, and so on till 10. I get A-10. And similarly, I'll run this 5 times for every data point or every data part coming as test data. I will run it and then I will draw a plot something like this. I will draw a plot which gives me accuracy, or a table. I can do this as a table also, and this is the value of max depth. So max depth starting from 2 going all the way till 10. Now I will go to the first model. This is my first model. I will see for a depth of 2 what is the accuracy. So I will plot it. So for the first model I will plot it, and I will call it, let's say, fold 1 or part 1. Okay. Similarly I'll do it for the other parts. Let's say this is for part 2. This is fold 2, and so on. This is fold 3, and so on. Now what will be my best? So you can see that your max depth value, it changes. It is not constant for every fold. So for example, for fold 1, which is blue, the max depth value is 6. The best max depth value is 6. For fold 2, the best value of max depth is around 4. For fold 5, it is again around 6. So then how do you decide which is the best value of max depth? You decide by drawing the average accuracy line. So these are lines for each fold. What we do is we average them. We average them, and then we draw a final accuracy line. So this is the final accuracy line that we are drawing here after averaging them. And then we check what is the best value of max depth on this final average line. So whatever this value is, this is what we finalize. This is what we finalize after doing cross validation. Okay, so the final value of max depth that we get is what you get after k-fold cross validation, which comes in this way. Now what is the advantage of this value of max depth? The advantage is that this will be more consistent. Your model will be more consistent with this particular value of max depth. Okay, all other values of max depth that you decide will be particularly for a one single test data. But if you do cross validation and then decide, then this is probably the best value of max depth given that training data. Okay, guys, are you following? I know if you have not watched last week's video, it will be very difficult to follow, but we are already running very late, so I don't want to wait for you guys to reach till that point. So I'm just covering it, and anyways this is being recorded, so you can always watch it later. But so far, did you get any idea of what is cross validation and why is it useful? This is a very important concept, guys. This is asked a lot in interviews, and also once you start working in data science, this is something which will be very helpful to you. And this is a little tricky topic. So cross validation, people take a lot of time to understand cross validation. I myself took a lot of time while I was learning to understand cross validation. Okay, so take this topic very seriously, and try to master this. This helps you a lot. So even if you are doing competitions on Kaggle or anything, this is one technique which will help you give a very good accuracy. Okay. Okay, now what remains is the code for cross validation. So let us see the codes. The codes are pretty simple, it is not difficult. So I will use the codes, the same codes that we had used for decision tree. So the poor care or the quality care data set, if you remember. So this is there in we had discussed this data in details. So here you are trying to predict if a patient is receiving poor care. Okay, so we had built a tree earlier on this data, and this is the confusion matrix we had seen. So we had gotten an accuracy of 85% on the training data and 80% on the test data. Okay, again this is also not overfitting because it is like random variation. 85% and 80% is almost the uh, same number of same range, or they are almost in the same range. So I would not say this is overfitting. Okay, so now if you see this clearly, I have used a min sample leaf of 3 here. Okay, I have used a min sample leaf of 3. So how did I come up with this value? So this is how This is where cross validation helps. So you can use cross validation and decide what should be that best value of min sample leaf, or what should be that best value of max depth. Okay, so this is decided using cross validation. So the codes for this is pretty simple. So what you do is first you, so let me run these codes. So it will take a while. Just files are big. So these codes are written in Python 2.7, but I have updated my Python to 3. So print function will require brackets. I did not have brackets, so it was throwing error. Okay. So this is the decision tree that we have here. Now let us see the accuracies. So these are the accuracies. Somewhere I have not given. Okay, it's here. Okay, so these are the accuracies 85 and this. Now let us try to. So here I have just given some random values of min sample leaf and max depth. Now in the next line of code, I will try to find these values using k-fold cross validation. Okay, so these are the codes. I'll directly copy them from here and I'll paste them here. So let us understand the code. So what is features? Features is equal to my calls. What is my calls? If you will see in the previous codes, my call I have defined it earlier. It is here. My calls is the name of the independent variables that I'm trying to use. So out of all the independent variables in this data, I'm just trying to use two. One is narcotics and one is days since last emergency room visit. Okay, so only these two columns will be taken as independent variables. That is what is my calls. Okay, now next is what is your dependent variable. So your dependent variable is data frame and poor care. This is the name of your dependent variable. I've given it as y. And what is my independent variable? I have just taken whatever columns are there in my calls, so my data frame name and then my calls. So this is my independent variable, this is my dependent variable. Okay, let me add a heading here. Okay, now let's say I have to decide the best value of max depth. Okay, so what I will do first, I will create an empty list. So I have created an empty list here. So depth is an empty list, and then I'm looking for best value of max depth between 3 to 20. So I have given range 3 to 20. So between 3 to 20, I'll look for the best value of max depth. It usually lies in this range. Next, I'm creating a tree with max depth of I, and this I is varying between 3 to 20. So I've created a loop and I'm rerunning this for every value of max depth that I give here between 3 and 20. Okay, and I'm doing a 10-fold cross validation. So you can see CV is equal to 10. That means it is 10-fold cross validation. So your data will be divided into 10 parts. Okay, just like we took 5, k is equal to 5 in the theory example, here I'm taking CV is equal to 10, or let me take 5 itself because the data is very small. So we usually take 5 or 10. If your data is big, you take 10. If your data is small, you take 5. I'll take 5 here because the data is small. And then you use the cross underscore val underscore score. So you use this function. So before using this, I'll have to import this. Let me import this function. So from sklearn dot model selection import cross underscore val underscore score. So we have to import this function. So after importing, then you can use this. So use this function and then give estimator is equal to CLF. Okay, x is equal to this small x. What is the small x? The small x is data frame. And so I'm running this on all the data. I'm not running this on just the training data. You can do that as well. So here I'm running it on the entire data, not just on training or test. I'm running it on the entire data. This is just for our learning. And y is equal to y. So you see I have given data frame poor care. So this is on the entire data, not just training or test data. And then cross validation is equal to 5. And next I'm calculating the score. Okay, the accuracy, the average accuracy for each value of I. And then I'm just printing it. So let me run this. So these are the values I get. That means at a max depth of 3, my accuracy is 77. At a max depth of 4, my accuracy is 78. At 5, it is 76, then 73, then 72. So you see it is varying. It is varying. My accuracy keeps changing. And what I will see, I'll try to find what is the value of max depth for which my accuracy is best. So the accuracy looks best for this value. For a value of 4, we have for 78%. So that means the best value of max depth is 4. The best value of max depth after cross validation is 4. Okay, so we build a final model using this value. So this is how cross validation helps you decide what is the best value of max depth. Now if you notice this carefully, we have not given any test data here. So we are not doing any cheating here. We are not going and looking into the test data and then deciding what is the best value of any parameter. We are using just the training data. So here the entire data we have taken as training data. So we are using just the training data to decide what is the best value of a parameter. We are not using the test data at all. Okay, because of the issue that we discussed, looking in the test data is like going into the exam and then coming back and preparing. So we are not doing that. So we are safe here. So is that okay, guys? Is this code okay? So I'll try to give a good homework assignment on this so that you guys practice and you learn. Okay, but is the code okay? Is the concept and code okay? Okay, so make sure you guys you are comfortable with this concept. Okay, this concept is very important. It is asked a lot in interviews, and while practicing also it gives you a very good advantage over others if you know this topic. Okay, if you know this topic, so this topic is what separates the beginners in data science to somebody who is not a beginner. Okay, So beginners generally try to avoid this because they don't fully understand this concept. Beginners, they will try to avoid this, but people who are experienced know why this is so important and they always use this. Okay, so make sure you are comfortable with this topic. If not, ask questions. Okay, ask questions, as many questions as you can. I have given a lot of videos on this topic. So if you go to the LMS, this has been explained in details. Cross validation is explained in details. So it is covered inside decision tree. So you will see a lot of videos on cross validation. So cross validation, keyfold cross validation, a lot of questions are there. Okay, so make sure you go through these. So here, instead of using the entire data to run the model, I could have just used the training data also. So let me try to do that. Instead of everything, let me use just the training data. So I'll use x underscore train, and here I will use y underscore train. Okay, I won't need these anymore. So let me run these. Okay, so the best value of max depth now is changing slightly. It is okay. It is 3 now. It is not. It is 3. Now we will use the max depth of 3 for prediction. So I'll build a final model now. So here CLF is your model. Okay, let me just write it down. So now I will build the model, final model. I'll call it final tree is equal to. I'll use the same function. Max depth is equal to 3 because 3 is giving me the best value. Okay, and then I'll finally use this for prediction. So let me call it pred is equal to this dot predict, and then I will pass the x of test data to make a prediction. So my predictions is done. Now I will create the confusion matrix. Okay, I have not fitted yet. Okay, let me fit the model first. I'll just copy paste. So I'll write final tree dot fit, and I will write x train and y train, and then I will go for prediction. Then I'll create the confusion matrix. First I will write the actual values. The actual values are in y underscore test, and the predicted values are in pred. Cross tab, right? Yeah, so this is my confusion matrix. I'll check my final accuracy will be 33 divided by 33 plus 7. Okay, this is my final accuracy. Print is small p. So 82%. This is my final accuracy that I have got after using cross validation. So if you go back earlier, on the test data I was getting 80% accuracy. Now I have slightly gotten better. I have gotten 82% on the test data. Previously it was 80% on test data because I had not used any cross validation. Okay, now I have used cross validation because without using cross validation I did not know what is the best value of max depth. So I had taken a max depth of 12, but max depth of 12 was resulting in probably an overfit tree. So now I did cross validation and I got to know that the best value is 3 and not 12. So I have taken 3 and I got slightly better on my test data. I got 82% on my test data. Okay. Yes, guys, any questions? Any questions, guys? So this is pretty much what I had for today's class. We had covered cross validation, remember, last week, last in the last class. I just wanted to walk you guys through the codes that are there in cross validation. You mean for cross validation, or in general you are talking, Sinoj? Yeah, so you need to practice more. The more you practice, the more comfortable you get. Yeah, that is okay. Sinoj, even for me, it is at times difficult without using Google. So that is okay. Using Google and writing the codes is okay. Okay, that is not something bad. But obviously, try to use minimal Google, or because it wastes a lot of time. At least you should know the functions that you should be using at the syntax and all. You can always Google. Even I do that. So that is not something bad. Without Google, it is always difficult because there are too many things. Okay, so that is not a problem. But try to get as comfortable as possible. Okay, so obviously for that you need to practice more and more. And with time you will get more comfortable, definitely. So guys, I'll try to put some assignment on this as well. So videos for cross validation I have already shared, and the codes is discussed in this particular video. So this particular video will be up on LMS, and I'll try to put some assignment or case study which requires you to use this cross validation and then come up with the best values of parameter. So whatever we did today is called parameter tuning using cross validation. Okay. So we were trying to tune the parameters, or we were trying to find the best value of parameters using cross validation. Yes, guys. So do you have any questions? Okay, Vineet has a question. I have a question related to running algorithm on large data sets. Yes, yes, of course, Vineet. You can ask any questions. So this was more of a doubt clearing session because I know you have not gone through the last class's video. So I wanted to touch base with you guys and see if you guys are facing any difficulty in any of the topics which has been covered in the past. So guys, one of the feedback that I got from all my previous batches was to have gaps between classes, because everyone had the issue that we're not able to be with the class. We are not able to sync with the class because there is a lot to study and we are falling behind. and this was the whole intention of giving you guys gaps in between. Okay, otherwise obviously even I don't like gaps in between, because I finish the batches sooner. So even if you see this as a as a business opportunity, it is actually bad for me, because the sooner I complete a batch, the sooner I can start a newer batch. But still I went ahead and I tried to give you gaps in between. But still I find you guys lagging behind. I still find a lot of you not logged into the LMS for quite some time. So I can track every moment that you do on the LMS, guys, by the way. Okay, so I know who is active on the LMS. I know who is not active on the LMS. I can know when was the last time you logged in and how much time did you spend after logging in. So I have seen a lot of people who have not logged in from the last 10 days, 15 days, and even 30 days for a few people. Even from the last 29, 30 days, you have not logged into the LMS. So obviously, guys, if you do this, then it is very difficult, right? If you don't study for 30 days, you forget everything. So right now, this is the the most important time for you. If you are learning data science, then this is, you are right now at a topic of decision tree. So this is the most important time to learn. So you should be at the at your very best. You should be giving your 100% at this point of time. And this time, if you don't log in for 20 days, then I'm very discouraged actually to see that, because I'm putting a lot of effort, guys. So please try to give effort. Okay, please try to give your best. Yes, Vineet, SVM as support vector regression on 2 lakh records is not going to end. Okay, so support vector machines is usually used for smaller data sets. Okay, and that too you are using a polynomial kernel. Don't use a polynomial kernel. Try a linear kernel. Okay, it will take a long time. It will never finish. 2 lakh is a lot for SVM. It is usually used for a few hundred rows, maybe 1,000 rows at max. Okay, so I don't think SVR will run on that. No, Anupama, this topic is not covered. So Vineet is asking something out of topic. So maybe Vineet is spending more time, and he's ahead of the class in some ways. Okay. So Vineet, are you still doing internship at Diomix? Okay, how is it going? Okay, great. So Vinith is doing internships at Diomix, guys. So Diomix is one startup which I am associated with. I have provided a lot of interns to Diomix who have later been absorbed by the organization, and they are now working as full-time data scientists at Diomix. Okay. So, but they usually have requirement for freshers. So, any other freshers in this batch who is willing to join and start a career in data science, then this is a wonderful company. Oh, you have converted full time already. You didn't tell me that, Vineet. You should tell me that, right? Ah, you should. You owe me a treat then. Yes, we will meet soon. So I'll tell you the story about Vineet. So Vineet was about to go into a 1 year full time course at some institute to pursue data science, right, Vineet? So he wanted to go into a 1 year course in data science full time. So which required a lot of investment. I asked him not to do that, and I asked him to come to Bangalore. He was without a job, and I asked him to come to Bangalore, and I helped him get an internship in this organization. And I'm so glad that he has converted that into a full time job. And obviously that is far better than spending 1 year full time not earning and taking a loan and going for a course. Okay, so we need to continue this hard work. I know you have worked very hard, so continue this. Don't quit right now. Okay, so it will take some more time to become further awesome. Okay.